Welcome back. This video is part 3 of a 9-part series on completing the square. In this video, we will discuss how to use the perfect square pattern discussed in the previous video to complete the square. I suggest that as you watch this video, you take your own notes. Get a pencil and some paper, and let's get started. Let's say you have the expression x squared plus 12x. According to the perfect square pattern shown in the blue box, what would we need to add in order to complete the square? First, we need to identify the value of b. This is the linear coefficient, which is 12. We also need to find the value of b over 2, which is 12 over 2, which equals 6. We plug into the pattern b equals 12 and b over 2 equals 6. We get the equation x squared plus 12x plus 6 squared equals x plus 6 in parentheses squared. 6 squared is 36, and so we get x squared plus 12x plus 36 equals x plus 6 in parentheses squared. From this equation, we can see that if we add 36, we will complete the square, and we can write the expression as a perfect square, x plus 6 in parentheses squared. Let's try another example, but this time with a negative number. Let's identify the value for b. In this case, b equals negative 10. b over 2 is negative 10 over 2, which is negative 5. If we plug into the perfect square pattern, b equals negative 10 and b over 2 is negative 5, we get the equation x squared plus negative 10x plus negative 5 squared equals x plus negative 5 in parentheses squared. Let's rewrite this equation. Plus negative 10x is the same as minus 10x. Negative 5 squared is the same as positive 25, and plus negative 5 is the same as minus 5. We get the equation x squared minus 10x plus 25 equals x minus 5 in parentheses squared. So adding 25 to the original expression will complete the square. Notice how in this problem, as well as in the previous one, we added rather than subtracted a value to complete the square. For this problem format, you will always add a squared quantity, which is always positive. Try these two practice problems. What do you need to add in order to complete the square? Pause now and try to do them yourself. For the first expression, b equals 4 and b over 2 equals 2. Plugging into the perfect square pattern, we get x squared plus 4x plus 2 squared equals x plus 2 in parentheses squared. 2 squared is 4, and we get x squared plus 4x plus 4 equals x plus 2 in parentheses squared. We need to add 4 to complete the square. For the second expression, b equals negative 16, b over 2 equals negative 8. Plugging into the perfect square pattern, we get x squared plus negative 16x plus negative 8 squared equals x plus negative 8 in parentheses squared. We can then rewrite it as x squared minus 16x plus 64 equals x minus 8 in parentheses squared. We need to add 64 to the original expression to complete the square. A typical problem would set our previous expressions equal to some constant. In this case, we have x squared plus 8x equals 111. These problems start off the same way as the problems you just completed. We identify b equals 8 and b over 2 equals 4. We plug those into the perfect square pattern and get x squared plus 8x plus 4 squared equals x plus 4 in parentheses squared. We replace 4 squared with 16, and we see that we need to add 16 to complete the square. We then add 16 to both sides of the equation to keep the equation balanced. We get x squared plus 8x plus 16 equals 111 plus 16. We evaluate the right-hand side and get 127. The left-hand side, according to our pattern, can be written as x plus 4 in parentheses squared. Our final equation is x plus 4 in parentheses squared equals 127. The steps for completing the square are first to find b and b over 2 and plug them into the perfect square pattern, and find out what we need to add to complete the square. Step 2 is to add b over 2 squared to both sides of the equation. Then step 3 is to write the left-hand side as the perfect square in the form x plus b over 2 in parentheses squared. Let's try another example, but this time with a negative number. X squared minus 2x equals negative 35. Identify b and b over 2. b equals negative 2 and b over 2 equals negative 1. Plug into the perfect squared pattern and we get x squared plus negative 2x plus negative 1 squared equals x plus negative 1 in parentheses squared. We can rewrite plus negative 2x as minus 2x, negative 1 squared as positive 1, and plus negative 1 as minus 1. We see that we need to add 1 to complete the square. We add 1 to both sides to keep the equation balanced, and we get x squared minus 2x plus 1 equals negative 35 plus 1. We can evaluate the right-hand side, negative 35 plus 1 as negative 34. The left-hand side, according to our pattern, can be written as a perfect square. We get x minus 1 in parentheses squared equals negative 34. Try these two practice problems. Complete the square. Pause now and try to do them yourself. For the first problem, we plug b and b over 2 into our perfect square pattern. From the result, we see that we need to add 4 to complete the square. We add 4 to both sides of the equation, evaluate the right-hand side, and then write the left-hand side as a perfect square. We get the equation x plus 2 in parentheses squared equals 104. For the second problem, we plug b and b over 2 into our perfect square pattern. From the result, we see that we need to add 64 to complete the square. We add 64 to both sides of the equation, evaluate the right-hand side, and then write the left-hand side as a perfect square. We get the equation x minus 8 in parentheses squared equals 83. An alternative method you may see to complete the square is to add and subtract from the same side of the equation rather than adding to both sides. This method works because this is the same as adding 0 to one side of the equation, which does not alter the balance of the equation. A portion of the left-hand side can be replaced with the perfect square x plus 4 in parentheses squared, and if necessary the remaining constant term can be added to the other side. We get the same result as the other method. If you would like more practice problems, you can easily create your own. Use the same structure as the equation below. The linear coefficient must be an even number, but can be positive or negative. We will go over how to complete the square with odd linear coefficients in a later video. The constant term on the right-hand side can be any number. It can be positive or negative. I recommend that you practice this form until you feel very comfortable solving problems of this type. That concludes this lesson. If you liked it, then click the like button below. In the next lesson, we'll discuss a shortcut to complete the square and also solve for x. See you in the next video.